Hi friends, this is Gautam. In this video tutorial, I am going to discuss about IP routing. So before going to watch this video, you have to go through my previous video session like OSI layer, IP version 4 packet header, Ethernet frame header, R protocol and default gateway. So if you watch this all this concept, then you can come back and you can watch this video, so you can able to understand this concept. So otherwise it will be difficult to understand the concept. Let's see. So the actual forwarding of IP packets by a routers is called IP routing. So this has nothing to do with the learning of network routes through static or dynamic routing protocols, but has everything to do with the steps that the router have to take when they forward an IP packet from one interface to another interface. Okay. So this is my example scenario. Here I am using two router and two PC. So R1 router connecting towards PC1. So here I am using 192.168.100.0/24. So router FA0/1 interface, I will assign the IP as 192.168.100.254, and PC1 I will assign the IP as 192.168.100.1, and R2 FA0/1 I assign the IP as 192.168.200.254, and PC2 192.168.200.1/24. So R1 and R2, here I am using 192.168.150.0/30 network, and R1 FA0/0 I will assign IP as 1, and R2 I will assign IP as 2. So these are the MAC address of PC1 and PC2, and this is a router interface MAC address. So above we have two computers and two routers. So PC1, now PC1 going to send an IP packet to PC2, which has to be routed by R1 and R2. Okay, so let's look at this step by step, device by device. So from PC1 I am trying to ping PC2 for an example. So let's start with PC1. So the host creates an IP packet with its own IP address as a source, and destination IP address is PC2 IP address. So from the PC, the first question that PC1 will ask itself is, this is the destination is local or remote? So from PC1 we have to give IP config, we have to check the IP, subnet mask and default gateway, and destination IP. So through the subnet mask itself we can comes to know the 192.168.200.1 is a remote network. So here we can say I will give IP config from PC1. This is the PC1 IP address and subnet mask and gateway. So from the subnet mask itself we can identify, because so here subnet mask is /24. So the starting IP should be 192.168.100.1 to 254. My destination IP is 200.1. So it's a remote network. So that one only I mentioned in this point. So PC1 is in a network 192.168.100.0/24. So all the IP addresses in the 192.168.100.1 to 254 range are local. Our destination is 192.168.200.1 is outside of the local subnet. So that means we have to use default gateway. So now PC1 will now build an Ethernet frame, enter its own source MAC address, and ask itself the second question: do I know the destination MAC address of the default gateway? So PC1 check its ARP table. So we have to give ARP-A. So here I have an entry for ARP, default gateway. So my default gateway is 192.168.100.254. This is the MAC address of my default gateway. So PC1 has an ARP entry for 192.168.100.254. If not, it would have sent an ARP request to figure out the MAC address of default gateway. So now we have an Ethernet frame that carries an IP packet with the following addresses. So source IP is a PC1 IP address and destination IP address is PC2 IP address. So source MAC address is PC1 MAC address and destination MAC address is default gateway MAC address. So default gateway MAC address is route 0 bar 1, this MAC address. 0003 E4B2 7102, and this is a PC1 MAC address. This is a source MAC address and this is a destination MAC address. Okay. Now R1. So this Ethernet frame makes it to R1, which has more work to do than our host. So from R1, first thing it does is check if the frame check sequence from Ethernet frame header. So frame check sequence of the Ethernet frame is correct or not. So this green color I highlighted. So if frame check sequence is incorrect, the frame is dropped right away. There is no error recovery for Ethernet. So this is something like in something that is done by protocol on upper layer like TCP on the transport layer. So in transport layer in TCP we have an error recovery feature, but in Ethernet frame header there is a no error recovery. So right away the frame is going to be dropped. So if the frame check sequence is correct, so we will process the frame if. So the first thing, the destination MAC address is the address of the interface of router, or the destination MAC address is a broadcast address of the subnet that the router interface is connected to, or the destination MAC address is a multicast address that the router listens to. So from this 3 point, in this case the destination MAC address matches the MAC address of R1 FA 0 bar 1 interface. So we will process it. So next one, we have to decapsulate and extract the IP packet from the Ethernet frame. So here we can see extract the IP packet, highlighted the IP packet in blue color from the Ethernet frame. So this Ethernet frame will be discarded. So the router will now look at the IP packet, and first thing it does is check if the header checksum is okay. So I highlighted in blue color. If from the IP packet, the router will check the header checksum is okay or not. If the header checksum is not correct, the packet is dropped right away. So in network layer also there is a no error recovery feature. So if header checksum is correct, we continue by looking at the destination IP address. So from the IP packet header, we have to check the destination IP address 192.168.200.1. So now R1, check its routing table, we have an entry or not. So 192.168.200.0/24. So we have an entry. The next hop is 192.168.150.2. So we can learn this network through static routing. That's why here it's showing yes. So second thing, the router will check the next hop is 192.168.150.2. So we have an entry for this next hop IP or not. So we have an entry 192.168.150.0/30. So this one is directly connected and we can reach through fast Ethernet 0 bar 0. So this one only we can say as a recursive routing. So above you can see that R1 knows how to reach 192.168.200.0/24 network. The next hop IP address is 192.168.150.2. So it will now do second routing table lookup to see if it knows how to reach 192.168.150.2. So we can call this recursive routing. So these 2 points only I explained previous slide. So as you can see, there is an entry for 192.168.150.0/24 with an, so this is an 30. So by mistakenly I written 24 is a 30 with fast Ethernet 0 bar 0 as an interface to use. Okay, there is one thing left to do with the IP packet before we can forward it. So since we are routing it, so we have to decrease the TTL from the IP packet. So R1 will do this, and since this changes the IP header, so we have to calculate the new header checksum. So time to live we can change from 255 to 254 and recalculate the header checksum. So that's why I have to highlight both time to live and header checksum. So once this is done, R1 check its ARP table to see if there is an entry for 192.168.150.2. that is a next hop IP. We have an ARP entry or not. So from R1 router ARP table we have an entry for 192.168.150.2. this is the MAC address of next hop. So no problem there, we have an entry in the ARP table. So whenever we don't have an entry, so through the ARP packet it will learn that next hop MAC address. So R1 will send an ARP request to find the MAC address of 192.168.150.2. So now R1 builds a new Ethernet frame with its own MAC address of the fast Ethernet 0/0 interface. So fast Ethernet 0/0 interface is this one, FA 0/0. So this interface MAC address is 0003.E4B2.7101, and next to IP is 192.168.150.2. So this MAC address is 0003.E478.E401. So R2 as a destination. So the IP packet is then encapsulated in the new Ethernet frame. So source IP is PC1 IP address and destination IP is PC2 IP address. So source MAC address FA 0/0 router and destination MAC address R2 router FA 0/0 interface MAC address. Okay, and the frame will be on its way towards the R2. So this Ethernet frame makes it to R2 like R1. It will first do this. So from R2 also, first it will check the frame check sequence of the Ethernet frame. Then next one it will check the destination MAC address. Then afterwards decapsulate the IP packet and discard the frame. Next one it will check the IP header checksum, then check the destination IP address. So R2 router, it will check the routing table, show IP route. We have an entry for 192.168.200.2. So here we can see 192.168.200.0/24 is directly connected, and we can use FA 0/1 interface. So 192.168.200.0/24 is directly connected to R2 on its fast Ethernet 0/1 interface. So R2 will now reduce the TTL of the IP packet from 254 to 253. So recalculate the IP header checksum and check its ARP table to see if knows how to reach 192.168.200.1. So from R2 router we can give show IP ARP. So we have an entry for 192.168.200.1. So the 000A F3CE.1B C9. So there is an ARP entry there. The new Ethernet frame is created and IP packet encapsulated, and it has the following address. So again source IP is a PC1 IP and destination IP is PC2 IP. So now here source MAC address. So source MAC address is R2 router FA 0/1 interface, that is an 0003.E478.E402, and destination MAC address is PC2 MAC address 000A.F3CE.1B C9. We can see here 000C.E478.E402 and destination MAC address PC2 MAC address. So now the frame is then forwarded to PC2. So from PC2 it will receive the Ethernet frame, then it will check the frame check sequence and find its own MAC address as the destination MAC address, and de-encapsulate the IP packet from the frame and find its own IP address as a destination in the IP packet. Then it will reply to that packet. So this is the normal communication from how the packet will be routed from PC1 to PC2. So the only thing is the source IP and destination IP, it won't change. In case if the source and destination IP will be changing, means the packet will be dropped. Only thing is source MAC address and destination MAC address is changing each and every hop the packet will be crossing. So that time only the source MAC address and destination MAC address will be changing. Okay friends, I hope you all liked this video. So if you have any queries, share your comments with me and reach out to me. Thank you friends. Thank you for watching my videos. Please subscribe my channel for further updates and share to your friends also. Thank you.